So this is Chapter 5, Quadratic Functions. This is going to be a video with the review B that I gave you in class. This is the explanation of how each of the problems are solved. All right, so let's begin. Here's our first problem. It says using f of x equals x squared as a guide, describe the transformation that yields this function. So the first thing that I want to do is take a look at my a term, and I see that it's 1/2. All right, so if a is greater than 1, it's going to be a stretch. And if a is less than 1, it's a compression. Stretch or compression, and if it's less, it's compression. Less, compress. All right, so, and it's outside of my parentheses here, so we know that it's going to be a vertical. It's less than 1, vertical compression. Okay, so we have a vertical compression. Now we also have this -9 with my x inside the parentheses, so that I know that that is going to be a shift horizontally, and it says -9, so that's actually going to be to the right, a horizontal shift to the right, 9 units. And then we're also going to shift up 4. All right, because the C term tells us the vertical up and down. All right, so there's your answer for that one. Next. All right, this one says consider this function and identify its vertex and its intercept. So I always just make a little T-chart here just to remind me that I have to have an X and a Y. So I'm going to look for my vertex and my Y-intercept. All right, so remember the y-intercept says what is y when x is 0? All right, so I'm just going to fill in 2 times 0 squared plus -6 times 0 minus 36. Well, that's going to be 0 plus 0 minus 36 equals this h of x, which is our y. So y equals -36. All right, so that goes there. So that's the easy one. Now to find the vertex, we're going to remember our quadratic equation says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so let me remind you that this -b over 2a, that is the vertex, all right, of our equation. And this other part, the b squared minus 4ac, that's going to be my discriminant, all right? And I don't need to worry about that right now, but I do want to pay attention to this -b over 2a. So that is -b over 2a. That's the x part. That's going to tell me my vertex. So I see that a in this problem equals 2, b equals -6, and c equals -36. So I'm just going to fill in my a and b here. So it says x is equal negative, and my b is -6 over 2 times a, which is 2. So negative times the negative is +6 over 4. All right, so that is the same as, we can reduce that, 2 goes in that 2 times, 3 times, so it's a +3 over 2. All right, so I'm just going to put 3 over 2, and you could put right in 1/2, and that would be 1 1/2, and that would be fine. All right, the next step that I'm going to do now is I'm going to go ahead, now I have my x, but I still need to find my y of that term. So I'm just going to fill this into my equation, putting my, I'm going to say y is going to equal 2, and then I'm going to say 3 over 2 squared plus a -6 times 3 over 2 minus 36. All right, and when I do all of that, and you can either work it out, you could just put it in your calculator or however you want to do that, you end up finding that y equals -40.5. All right, so my vertex is at -40.5. All right, so here's your answer to this question. All right, next. This one says find the minimum or maximum. So first of all, we have to figure out when we're looking for the minimum or maximum, we're looking for this A over here. If it's positive, I'm going to have a parabola that is pointing up on both ends, and I will actually have a minimum. So this is the smallest point, the lowest point that I can use in my y. So if I have it like this, it's a minimum. If my a had been negative, then my parabola would have looked like this, something like this. And here my vertex is going to be a maximum. That's the highest that my x can be. So in this case we have positive, so we're going to actually have a minimum. And the minimum is going to be found at the vertex, okay? And that's the axis of symmetry. So let's use our equation to find our vertex, negative b over 2a. All right, so here I see that a equals 1, b equals negative 2, and c equals negative 48. So I'm going to go ahead and just fill into my equation here. It's going to be negative b, which is negative 2, over 2a, which is 1. So my x component of my minimum is going to be negative 2 times negative 2 is positive 2 over 2, which equals 1. So that's the x term. So my x is going to equal 1. Now I have to find my y term because that's where my minimum is going to be. And so let's go ahead and just fill in 1 back into our original equation. So 1 squared plus negative 2 times 1 minus 48. All right, so 1 squared is 1 plus a negative 2 plus negative 48, and that equals negative 49. All right, so my minimum is going to be found at 149, negative 49. So that's what my final answer is. Next. Number 5 says find all the zeros of the trinomial. So what I'm going to do is go ahead and set this equal to 0 because I just want to remember when it says find the zeros, I have a parabola, so I know I'm going to find 2 zeros. When y is 0, there's going to be 2 different x's, all right? So the first thing I'm going to look at is what is the easiest way, and always the easiest way to try and do this is if you could factor first, okay? So always think, can I factor this out in any way? And so I'm going to look at this and say, okay, I'm looking for 2 numbers that multiply together to get negative 200, add together to get 10. Well, I know that negative 20, no, not negative 20, positive 20. Positive 20 and negative 10. Multiply together to get negative 200, add together to get 10. So this one's pretty easy. X plus 20 times x minus 10 is going to equal 0. Because remember, I'm trying to find my zeros. So if x plus 20 will have to equal 0, or x minus 10 will have to equal 0. Because if x equals, in this case, minus 20, so x equals negative 20. If x equals negative 20, the whole thing is 0. And if x equals positive 10, the whole thing also equals 0. So when the question says find all the zeros of the trinomial, we see that we'll have a 0 at x equals negative 20 and at x equals 10. All right, you can do either of those and that would be fine. Next, this one says solve. So, oops, I've already written the answer there for you. Anyway, all we need to do is say 225x squared equals 9. So let's just divide 225 by both sides. Divided by 225. So I end up with x squared equals 9 over 225. Now when I see the word solve, I wanted to say x equals, but right now I have x squared. So I'm going to square both sides. So I end up with x equals square root of 9 over square root of 225. And remember, this is plus or minus, all right? Because there's two spots on our parabola that hit when y equals 0. We have 2, so we have to have two answers here. So x equals square root of 9 is 3, plus or minus 3. Square root of 225 is 15. And that can be reduced to x equals plus or minus 1 over 5. And that's your final answer. All right, let's go to the next problem. Number 7, write a quadratic function in standard form having zeros of 2 and negative 11. So remember, the quadratic function in standard form is ax squared plus bx plus c. All right, so we'll just call that f of x. All right, so we know that the zeros are 2 and negative 11, so it must have been x minus 2 times x plus 11 equals 0. Now that I have that, I can just FOIL this out, and I'm going to end up being in the right format. So when I FOIL, I multiply the first terms together. It's going to be x squared, and the outer terms together plus 11x, and the inner terms together plus a negative 2x, and then the last terms together, negative 22. All right, and all of that would equal 0. And now we're just going to put everything together, x squared plus 9x minus 22. And that would be your final answer. All right. And it says write a quadratic function, so we would actually say f of x equals that. Okay, number 8. Identify the vertex. Now, this should be really easy to use. So, because remember, the quadratic equation in vertex form tells us what the vertex is. It's a times x minus h squared plus k, and h and k are the vertex. All right? So, h is 14. K is negative 8. Now, I want you to be really careful because this says plus, but my formula says minus. So whatever is inside here is going to be the opposite. We want to know what would make this whole thing 0. And actually, it would be negative 14 would make that whole thing 0. And when negative 14, when x is negative 14, then y would be negative 8. So there is your answer. Number 9. All right, in this problem, we're going to complete the square. So what we want to do is go ahead and we're going to set it equal to 0. So we're going to just say x squared minus 8x minus 17 equals 0. And the first thing, if I just looked at this and didn't know what I was supposed to do, I would try and factor it first. I'd try and find two numbers that multiply together to get negative 17, add together to get 8. And I would see, oh, I can't do it that way. So the next thing I'm going to do is try to complete the square. So I'm going to go ahead and I'm going to add 17 to both sides. So I end up with x squared minus 8x. And since I'm going to complete the square, I'm going to go ahead and fill in equals 17 plus a number. All right, so I'm going to look for that number that's going to go here. And the number that I want is going to be negative 8 divided by 2. It's actually going to be b divided by 2 squared. So negative 8 divided by 2 is negative 4, and negative 4 squared equals 16. So that's the number that I'm going to put in both sides. If I add 16 to one side, I have to add 16 to the other side. Now when I look at this equation, I can say what two numbers multiply together to get 16, add together to get negative 8. And I know that that is negative 4. Negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8. So this actually factors out now nice and easy. X minus 4 times x minus 4. And that is going to equal 33. So now I'm almost finished. This is the same as x minus 4 squared equals 33. but it tells me to write it in vertex form. So let's remember what vertex form is. Vertex form is a times x minus h squared plus k. So I'm going to just go ahead and subtract this 33 back over to this side. So I have x minus 4 squared minus 33. And that would equal 0, or written out c of x instead of 0. X minus 4 squared minus 33. And there is your answer. Okay, next. All right, this problem says we want to simplify negative I to the 7th power times the square root of negative 72. So the first thing I'm going to do is rewrite this a little bit. I'm going to just put that understood 1 in as negative 1 I to the 7th times the square root of negative 72. So I'm going to do each of my pieces. I'm going to go ahead and drop down my negative 1 and bring that on down. Now I'm going to deal with this I to the 7th. There's lots of different ways that you can deal with I to the 7th. I like to deal with I to the 7th by saying this: I squared times I squared times I squared times I. 2, 4, 6, 7 i's. All right, so I to the 7th is written, could be written like this. Now there's other ways that you could do this. You could divide by 4 and follow that pattern. I sometimes get confused unless it's a really big number, then I have to work out all the patterns, but since we're using small numbers here, we're not going to have to worry about that. So I squared, remember, here's 2 things to remember. I is equal to square root of negative 1, and I squared is equal to negative 1. So if I squared is equal to negative 1, that would be the same as negative 1 times negative 1 times negative 1 times I. So, and negative 1 times negative 1 is positive 1 times negative 1 times I. So I can see that I to the 7th is equal to negative 1I. All right, so instead of writing I to the 7th here, I'm going to write times negative 1I. Okay, so I know that negative 1 times a negative 1 is a positive 1. So now this whole term right here, negative 1 I to the 7th, is equal to I. All right, now we're going to deal with our square root of negative 72. Okay, so I have I, and I'm going to rewrite square root of negative 72 as negative 1 and square root of 72. All right, so here again I have this square root of negative 1 is the same as I. So I'm going to bring my I down here, and then this I, okay, so that I is there. This I is also going to be I. And then we have square root of 72. Well, look at this. I have I times I now. So I actually have I squared. And I squared equals negative 1. All right, so let's take a look at negative 72. That's made up of 9 times 8. So negative square root of 9, is the same as 3. And times 8, square root of 8, which is 2 square root of 2. So in the end, I have negative 3 times 2 is negative 6 times the square root of 2. And that's your final answer. All right, number 11 says to solve. All right, and I've already got my answer here, but let's do it anyway. So I have 9x squared plus 25 equals 0. The easiest way I know to do this is just subtract 25 from both sides. All right, and we end up with 9x squared equals negative 25. Now this is very similar to one that we've done earlier, but this time we have the negative. So you can tell that what I'm wanting you to show me is that you know how to deal with those negative numbers. So we're going to divide both sides by 9. We end up with x squared equals negative 25 over 9. Now I want it to be, since it says solve, I want it to say x equals. So I'm going to go ahead and square everything. So I end up with x equals plus or minus square root of negative 25 over square root of 9. Now I know that square root of 9 equals 3. So we're going to say x equals plus or minus. I'm going to go ahead and do the bottom one easy. Okay, now the top one, square root of 25, is the same as square root of -1 times square root of 25. All right, and we know square root of -1 is I, and square root of 25 is 5. So in the end, our answer is going to be 5I over 3. Okay, next. Okay, number 12 says use the quadratic formula to solve. So let's remember our quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's figure out our a, b, and c. A equals 3, b equals 6, and c equals 4. All right, so let's plug it all in. X equals -b, which is 6, plus, come here, sorry. Let's do it. X equals -b plus or minus the square root of b squared minus 4ac. A is 3 and c is 4. All over 2a. All right, so here we have x equals -6 plus or minus the square root of 36 minus 48 all over 6. All right, so now we have x equals -6 plus or minus square root of -12 all over 6. Now we have to reduce this, so let's check and make sure we know what our -12 is. Square root of -12 is equal to square root of -1 times square root of 12. So that is going to be -1 is an I. 12 is going to be 2 square root of 3. You should have that memorized now. So that is going to be 2I square root of 3. So we have x equals -6 plus or minus 2I square root of 3 all over 6. Now, what you need to do is remember that these are actually two separate problems, but they have a common denominator. So it's -6 over 6 plus or minus 2I square root of 3 over 6. Now I can reduce a little bit. This is going to be -1 plus or minus 2 goes into 2 one time, 2 goes into 6 3 times. So it's going to be I square root of 3 over 3. So that's what your x equals. And if we didn't have an I, we would actually work it out. But since there's an I in there, you can just leave it like that. All right, number 13. This one says, for the discriminant, identify the number of solutions and their types. So let's think about what the discriminant is going to tell us. All right, if the discriminant is equal to 0, that means our parabola is touching, the vertex is on the x-axis. All right, it could be like this also. So that tells me that there is one real solution. Okay? If my discriminant is greater than 0, that means it's a positive number. A positive number. That tells me that my parabola is going to be something like this. I'm going to have two real solutions. All right, and if my discriminant is less than 0, that means it's negative. That tells me that my parabola is never going to cross that x-axis. All right, it's going to be something like that. So we're actually going to have, because remember it's going to be plus or minus, we're actually going to have two complex solutions. Okay? So we'll have two complex solutions. So let's take a look at our discriminant here. Square root of 4, be careful, that's square root of -4, so that's actually going to be 16. We don't even have to put the square root on there, the radical sign. So it's going to be 16 plus negative 8. All right, so 16 plus negative 8 equals 8, and that is, it's greater than 0, and it's positive, and so that tells me that I have 2 real solutions. Okay, and that's your answer right there. All right, next. So here it says to solve, and notice that we have to be careful on this because it's got an inequality sign here. It's less than. So what I'm going to be doing is I'm going to be thinking about what is going to be shaded. Okay, so let's just say my parabola is like this. All right, and if I'm either going to be shading everything on the outside of my parabola, or I'm going to be shading everything on the inside of my parabola, okay, because it's an inequality. So I'm going to have lots of different solutions. Now, here's what I want you to think about. If I chose a point out here in this first example, this would be true. If I place that point back into my equation, this point would be true. Anything inside here would be false, and everything on the outside would be true. If I chose a point on this one, if I choose a point out here, this one's going to be false. This one point, if I choose a point in here, it's going to be true. And if I choose a point out here, that's also going to be false. So you can see the pattern. It's either true, false, true, or it's false, true, false. But we don't have to look at this whole thing. We can just really look at these 2 major points, and it divides my graph into 3 different regions, okay? The 3 different regions. So here's a region, here's a region, and here's a region. So we can check all of those regions and figure out what the shading is going to look like. So let's take a look at this equation first, and let's go ahead and set it equal to 0 to get started. So we're going to say 3x squared minus 3x minus 6 equals 12. And I want to set it equal to 0, so I'm going to subtract 12 from both sides. And I end up with 3x squared minus 3x minus 18 equals 0. All right, so next thing I'm going to look at, before I do anything, I'm actually going to see that I can factor this out. And this time I have a 3 here and a negative 18. And I don't really like to have a 3 there, but since I do, what I'm going to do is I'm going to make my x here. I'm going to solve this a little bit differently. Actually, I'm not. I'm going to go ahead and factor out a 3 out of all this. I can factor out a 3. That's going to leave me with x squared minus x minus 6 equals 0. Okay? And then I could actually divide both sides by 3, and that kind of eliminates my 3 in my equation for right now. So I end up with x squared minus x minus 6. So I'm going to think, what 2 numbers multiply together to get negative 6 and add together to get negative 1? All right, well, that should be pretty easy for you. The 2 numbers would be negative 3 and positive 2. So my equation, my factored out equation is x minus 3 times x plus 2. And all of that equals 0. So x is either going to equal positive 3 or x will equal negative 2. All right, now that I know those 2 points, then I'm just going to go ahead and just kind of sketch out, and I'm going to put my major points. I've got a negative 2 here, and I've got a positive 3 here. Now, in the interest of time, it would be really nice if you had the time to just go through and pick a point on all 3 sides, in all 3 areas, and test it. But when you're taking a test, we really don't have time to do that. So I want you to just choose one point, and let's choose this point right here in the middle, 0. Okay, let's just test 0. So let's go back to our original equation up here. and says 3 times 0 squared minus 3 times 0 minus 6 is less than 12. So basically, these are zeros, so is negative 6 less than 12? Yes, it is. So that means, since I picked the one in the middle and it said, yes, this one is true, that tells me that this is true and this is going to be wrong and this is going to be false. Both of those two will be false. So I know any number that I choose within this range is going to be a true statement. So next, what we want to do, notice that there's just one section that's going to be true. So I just have to write one equation. So I'm going to write negative 2 and 3. I'm going to put my x in the middle. X has to be greater than negative 2 and less than 3. So notice that I just have one complete piece right here. All right, because there's just one section here. Now our next problem, number 15, is going to be the other way around. So let's do that. Okay, again, we're going to go ahead and set this equal to 0. So negative 2x squared plus 7x plus 30 is equal to 15. We're going to say that right now. Let's go ahead and subtract 15 because we're trying to find when y is 0. So we're looking for the zeros. So we've got negative 2x squared plus 7x plus 15 equals 0. All right, this time's a little bit different because when I multiply two numbers together to get, let's see, I can't factor anything out. So I'm going to have to do my math a little bit differently to factor. So here's what I'm going to do. I'm going to multiply negative 2 times 15. So I'm going to have negative 30. I want two numbers that multiply together to get negative 30, add together to get 7. All right, well, let's see. 30 and 1, no, that's not going to work. 15 and 2, that doesn't work. 3 and 10, that does work. 10 and negative 3. All right, 10 times negative 3 is 30, and 10 plus negative 3 is 7. So what I'm going to do is I'm going to change 7x. I'm going to change that to 10x plus negative 3x. All right, they're still the same. 10 minus 3 is 7x. Then I'm going to just bring everything else down, plus 15 plus negative 2x squared. All right, now I'm going to group these together and I'm going to group these together. And I'm going to look at this and see, I can factor a negative 2x out of there. So I'm going to factor the negative 2x. That leaves me with x minus 5. Over here, I see I can factor out a negative 3 plus negative 3, and that leaves me with x minus 5 also. So now, looking at my equation, I see that I have a negative x minus 5 in both terms, so I'm going to factor that out, x minus 5, and that leaves me with negative 2 plus a negative 3, and all of that has to equal 0. So either x minus 5 equals 0 or negative 2x minus 3 equals 0. So we know that x is going to equal 5, and let's add 3 to both sides here. So we have negative 2x equals 3. Divide both sides by negative 2. We have x equals negative 3 over 2. All right, so those are our key points. Now that we have our key points, let's just draw our line here, and let's put them in here. So we have a negative 3 over 2, and over here we have a 5. Now, I have divided my graph into 3 sections. This section, and finally this section over here. So if I had a lot of time, I would check all 3 points, but since this is a test, I'm only going to check 1 point, and I'm going to check the 0 right here. So what I'm going to do is go back and fill in 0 and 0, so I end up with this little piece of an equation right here. It says, is 30 less than 15? No, it is not. So I know this is a no, and if that's a no, then this must be a yes, and this must be a yes. Okay, so I have two pieces here, so I have to have two separate, x equals two separate things, all right? So what I'm going to do is notice that my arrow is going to the left, and so I'm going to make my arrow go to the same way. So on this side, I'm going to say, okay, x has to be less than negative 3 over 2. All right, notice the less than is going the same way as my arrow there. Or x has to be, notice that I have an arrow going this way, so I'm going to make my inequality the same way, 5. So I have two checks, and so I have to have two pieces of my answer. All right, so x could be anything that's less than negative 3 over 2, or x can be anything greater than 5. All right, we're headed down to the home stretch now. Number 16, write a quadratic that fits this equation. All right, so what we're going to do is, we could do it any way we want, but let's just go ahead and set this up so I can remind you what's happening, and then I'll show you the shortcut. Okay, so remember, a quadratic equation is going to be ax squared plus bx plus c. Now I'm given an x and a y, an x and a y, and an x and a y. Okay, so ax squared plus bx plus c, we're going to set that equal to f of x, and remember, f of x could also be y. So now I'm going to take each of my terms. So my first term is going to be, or coordinate, is going to be negative 4, comma, 126. All right, so this is my x and this is my y. So I'm going to go ahead and fill it into this little form here. A times 4 squared plus b times 4 plus c equals y, which is 126. 126. All right, so that is 16a plus 4b plus 1c equals 126. All right, the next one, I'm going to do 2, negative 12. 2, negative 12. All right, so again, we're going to say a times 2 squared plus b times 2 plus 1c equals negative 12. All right, so that's going to be 4a plus 2b plus 1c equals negative 12. And now I'm going to use my last point, 554. Again, we're going to do the same thing over again. A 5 squared plus b times 5 plus 1c equals 54. So that would be 25a plus 5b plus 1c equals 54. Okay, now I have 3 variables and 3 equations, 1, 2, 3, and you could solve them any way. You could solve them with elimination, you could solve them with substitution. I particularly like to solve them with the matrix on your calculator. That's the easiest way to do this. So let's just solve this with our matrix. So what we want to do is go ahead and make up a matrix system, and we see that our matrix is going to be 6, 4, 1, 126. So we're going to put 6, 4, 1, 126. And my next one is 4, 2, 1, negative 12. 4, 2, 1, negative 12. My last row is going to be 25, 5, 1, and 54. Okay, so we put that in your calculator, and then go to RREF, and we will end up with a matrix that should look like this. It'll be 1, 0, 0, 5. Actually, is that negative? I think it's positive 5. And then 0, 1, 0, negative 13. And then 0, 0, 1, negative 6. So that's what you should see. So your equation is going to say f of x equals 5x squared plus negative 13x minus 6. Okay. Now, What I do when I'm looking at this, I don't write out any of this. That's too much work. All right. I just go ahead and start, and I usually write it backwards. I start with my y's, and I get all my y's put in. So I see I have a 126, I have a negative 12, and I have a 54. And then my c's, I know my c's are all going to be 1, so I just put those in. My b's are just going to be the exact term that I have for my first x, so that is going to be negative 4, 2, and 5. And then the last one is just the first x term squared. So negative 4 times negative 4 is positive 16. 2 times 2 is 4. And 5 times 5 is 25. So I go straight to the matrix, fill it in, and then get my answer that way. A little bit faster, but if you need to do it the long way just to make sure you get it right, that's fine. But the main thing is on this that you use your RREF in your calculator and do the matrix. So I think everybody knows how to do that. All right. Okay, for this example, I'm not going to be able to do it right now because I can't pull up my calculator, but basically what we want to do is input in the y equals section. You want to go ahead and put in negative 16x squared plus 20t plus 50. Oops, not 20t, 20x. So just use x in your calculator. Plus 50. Okay, so it wants to know what is the time. How long did it take? So we're looking for t, and in this case, that's going to be our x. So we're looking for x when y is 14. So once you've input that in, you want to go to table, and it'll give you a graph of x's and y's. And so you're looking for your y to be 14 and whatever the x is, and in this case it's I think it's 2.25 is your x. So sorry, I can't really help you with that one. All right, do number 18. So on this one we need to simplify. All we need to do is remember that square root of negative 1 equals I, and that I squared equals negative 1. So I'm going to just multiply the top and the bottom by I. And when I do that, I can distribute this I to both of these two pieces. So I end up with 7I plus 11I squared. And all of that is over I squared because we don't want to have an I in our denominator. So let's clean these up a little bit. Remember, I squared is equal to negative 1. So this is just negative 1 down here. And also, I squared up here is also negative 1. So 11 times negative 1 is negative 11. And we have 7I. So 7I minus 11 over negative 1. So I don't like having that negative there, so I'm going to go ahead and multiply both the bottom and the top by negative 1. It's just another picture of 1. So now I'm just going to distribute. Negative 1 times negative 1 is 1, so that goes away. I'm going to distribute my negative over 1, so it's going to be negative 7I plus 11. All right. And remember, this is correct, but remember this should be written in A plus BI form. So it's actually going to be 11 minus 7I is your final answer for number 18. All right, number 19. Okay, number 19. This is just a simple foiling problem, but it's a little more complicated, so let's FOIL it. This is going to be 2/3 times 3 plus negative 2/3 I plus 12I minus 4I squared. Okay, so now I'm going to cancel that, so I have 2, and I'm going to look over here. This is plus a negative 4, so I have a negative 4 times I squared, and I squared, remember, is negative 1. I squared equals negative 1. All right, so negative 4 times negative 1 is 4. 4 plus 2 is 6. So we have our terms like that are 6. Next, I have plus negative 2/3 I plus 12i. Now remember, our I acts just like a variable. And these are, so these two terms are the same. So negative 2/3 I, that is actually 0.66i plus 12i, and that actually equals positive 11.33i. So our answer is 6 plus 11.33i. All right, so there it is, 11.33i. There you go. Next, the last one. Here we go. So on this one, the main thing you should remember when we see a problem that's written in the A plus BI format, remember this term is our x and this is our imaginary. So we have an x-axis, but then we have the imaginary axis. So this point right here is actually over -3 on the x-axis. And then it says down 1 because that's plus a -1. So we have a point right here. And remember, absolute value tells us how far from our point to 0. What is the distance to 0? So if I'm going to walk this distance, what is the distance I'm walking? I can't have a negative step or anything, so it can only be positive. So keep that in mind. So if I want to find this distance, I can remember the Pythagorean theorem. Says a squared plus b squared equals c squared. All right, but I want to know what the difference, what that is. So I could just say a squared plus b squared equals c squared. I want to solve for c actually, so I'm going to square root everything. So I know that c equals the square root of a squared plus b squared. So on this problem, it says I went to the left 3, so that's, we're going to call that our A. So that's going to be -3 squared plus our B, I just went down -1 squared. So I end up with -3 squared is 9 plus 1. So C equals square root of 10. So my answer is just square root of 10. The distant absolute value is square root of 10. So don't be tricked by this, because you could have any kind of I to the 5th, I to the 3rd, I to the 4th, anything. We don't even have to worry about that at all. Don't even worry about that at all when you're doing the absolute value using imaginary numbers, because it's the same as what it would be if you were using real numbers. It's just on the complex grid. The imaginary grid. Okay, so that's all the problems that you're going to see on your test. I hope this helped you, and you guys have a good day, and I'll see you in class. Bye.